So we're continuing on with our programming. So far, right now, we've inputted our left bound and our right bound of our of the area that we're looking at. So once again, going back, thinking about what we were doing before, finding the area of ln x from 1 to 5. 1 was our left bound, and 5 was our right bound. So our left bound, our right bound. Now what we want to do is tell our calculator whether we want to use left bound, right bound, or midpoint. And so we're going to call that x choice. So again, go to program, go to input, output, input, and we're going to input x choice. And x choice is going to be a numerical way of talking about it's x choice is going to be a numerical way of talking about left bound, right bound, or midpoint. 0 is going to stand for left bound. 1 is going to stand for right bound. 0.5 is going to stand for midpoint. So you're going to have to remember that. That's something that students often forget, but that's part of that's the way that this program works. So we've got our x choice, and we're going to store our x choice in C. So what we're doing, we inputted our left bound that stored that as value A. Inputted our right bound, stored it as B, and now we're inputting whether we want to do 0 for left, 1 for right, 1/2 for midpoint, and storing that value in C. The next thing that we're doing is we're going to determine the length of the width of our subintervals. So, if I have my right bound and my left bound, b minus a, this b minus a, that's the distance between them, divided by, oh wait, I got ahead of myself. Now we need to input the number of subintervals that we want. So, program, input, output, we want to input, let's alpha lock it, we want to input the number, and the number is how many, that's our n value, it's how many intervals, or subintervals rather, we're going to have. In other words, like if n was 5, then we're going to have 5 rectangles. If n was 10, then we're going to have 10 rectangles. You get the point. And we're going to store that as n. Then, okay, now what we're going to do is we're going to do this calculation of b minus a, where b is my right bound, a is my left bound. So b minus a is the total distance of the area I'm looking at. Sorry, the total length for the area. And I'm going to divide it by n, and that's going to tell me the width of each subinterval. And I'm going to store that, so go down to store. I'm going to store that in H. So in other words, what that's doing, b minus a is this distance from 1 to 5. And then we're dividing it by how many subintervals there are. So we had 4 divisions. So 5 minus 1, that's b minus a, is 4. Divided by 4, so when we divide it by 4, 4 divided by 4 is 1. So that gives me each of these is a width of 1. So now we need to, this is a pretty complicated program in that it's using some sophisticated programming language. But what we're going to do is we're going to let s, where s is going to be the variable that counts the area. So s is the sum of our area. We're saying it's going to start at 0. So we're just saying that initially we have 0 area. So our sum is initially 0. S stands for our sum. And what I'm going to do is I'm going to create this what's called a for loop. So I'm going to add up all of the different. I'm going to add up all of the areas of the rectangles given that we already have a left bound, a right bound. We've decided whether we're using a left, right, or midpoint, and how many intervals there are. So we've given the calculator all the information it needs. Um, so we need to put 4, so go to Program and go down to 4, and that's for I, so alpha I. And to be honest, um, if you really understand this program, that's awesome. If you understand sort of how it's working. If you don't totally understand, well, we just really introduced Riemann sums, so I imagine that the program language is pretty difficult given that you're just beginning to work with this topic. But I think it's helpful for you to have this program just so that you can check your work and that so you can generate some Riemann sums for huge values of n. So we did this for loop, and then what we're doing now, we're computing the x value used as input for y1. That's what this line is doing here. So we have to say, oops, alpha a, where a is my left bound, plus I minus 1 plus C times H. So this A is my left bound, and then this is incrementing me by the appropriate increment lengths. H is my increment amount, and this 1 minus I minus 1 plus C, that's essentially just sort of stepping me up subinterval by subinterval. And we're going to store that as x. So store that as x. And then I want to add up all the y values. Um, so alpha s, so that's my sum. And then I'm going to add up the y values times the x, the corresponding x. So to get y1, we go to vars, yvars, function y1, parentheses x times h. And so the y1x times h, that's the y value times this times the x value. This is giving me the height times the width of my rectangle. Again, um, I'm more interested in you getting this program, and eventually you're going to really understand it. But for now, it's just a tool that we're generating. Um, and now that's our program. So we're going to end our program. So go to Program, go down to End, and then what we want to do is display the sum. So go to Program, Input, Output, go down to Display, and what we're going to do is display the sum. So we want to put parentheses SUM to say we are displaying the sum. And then, so anything in parentheses, it's just going to display exactly that. But now what we're going to display is S, where S is our stored value for the sum. And then once we're done that, we're going to stop it. So Program, scroll down, and way down there is stop. So now my program is over. Now, so how this works, you need to put a function into y1. So if I wanted to, for example, if I wanted to find out a left bound approximation for ln x from 1 to 5 using my calculator program, second quit, what I would do is in y equals, I have to put in my function ln x. So ln x. And then once I have my function in there, into y equals, so my function is in y equals. Once it's there, I am going to go into Program. Here's my program. I'm going to press Enter to execute it, Enter to execute it. So my left bound, well, what's my left bound? My left bound is 1, so I enter in 1. Right bound, well, my right bound is 5, so I enter in 5. X choice, well, I want to do a left bound, and remember X choice is 0 for left, 1 for right. So my X choice, I'm going to put 0. Number, how many subdivisions I want. Well, I want 4 subdivisions, so I press 4. And what it does for me so nicely is it kicks out the sum. It tells me um, that my area approximation is 3.178, and that's what I would get if I were to, if I were to have added ln1 plus ln2 plus ln3 plus ln4. Let's just confirm that. So, ln1 plus ln2 plus ln3. We have 1 times all of these, but 1 times 1 times, but that doesn't matter. Plus ln4. Hopefully we're going to get the same area approximation, and we do. So this program that we just generated together will save you a lot of time when you're doing Riemann sum approximations. That's it. Okay. Uh, you need to have this program on your calculator if you have an 8384 coming into class the next time. So make sure you get this programmed. If you have no idea, if you're really stuck, well, I think you shouldn't be stuck. I think you should be able to figure this out. But if you're really, really stuck, you can get help from me or get help from someone else. But make sure that you have this program coming into the class next time. Thank you.